I'm about to show you how to fix a 4K Sony OLED TV with a dead no power symptom. My name's Nick. I started Nick's Electronics Repair about a decade ago, and since then have fixed over 27,000 devices. All right, let's begin our diagnostic. Now I have the power supply here today. However, for most Sony TVs, a dead no power symptom is usually the main board. The customer sent us both devices, so let's first start with the power supply. I have my multimeter in DC mode. Let's do a voltage check on the filter caps. We're getting 168 volts. Next, let's check our standby voltage on pin number 6 over here. And we're getting 3.5 volts, so that's correct. Now the power supply is actually not fully on right now. It is in standby mode. We're gonna be using this jumper wire to trick it into fully turning on. What this jumper wire does is jump the standby voltage to the power supply on command. It also does the same for the T-Con. As I plug this in, I'm supposed to get a click, but I did not. So let's take a look. Do we get our 12 volts? And we do not. Now, I've actually spent a lot of time trying to identify and figure out what is wrong with this power supply, and I was not able to until I used the infrared camera. And if we take a close look, we see there is a part that is getting really, really hot. We're at 120 degrees, and that's Celsius, not Fahrenheit, but Celsius. And if we zoom in, oh wow, it's already at 170. Okay, let's disconnect. So this is the area that was getting hot. What I'm gonna do is I'm going to spray it with isopropyl alcohol, and we're gonna plug the power supply back in. We're gonna take a look. What gets dry really fast? And that was very obvious. So I just disconnected it again. Right here, this Q303 SMD transistor is looking like it's getting very, very hot very quickly. The IC over here also got pretty hot. Let's go ahead and plug it one more time. And yep, so it's drying up in the center. Let's go ahead and unplug it. Now this IC is in line with the transistor, so I'm curious if perhaps the transistor being shorted causes the IC to overheat. What we're gonna do is check for shorts. So we're gonna be in continuity mode. We gotta be able, when we find a short, let's check, no short, and no short. Let's see the outside pins here, no short. So here's what I'm thinking, because I've worked on a lot of these power supplies and I've never seen this failure before. I'm thinking let's remove the SMD transistor first because that is the smaller component and is also the one that's getting the hottest. That was the one that was detecting 170 degrees Celsius. For the removal process, we're gonna start by adding some solder first, get good flow. And it looks like the component might have physically gotten damaged there from the removal, which is not entirely surprising given how hot it got. Let's go ahead and give the IC a new spray. Let's plug it in and see if we still get to these high temperatures. And you know what? I think I just heard the power supply click and the IC chip's not getting hot. All right, let's do one more test. We're gonna plug the power supply back in. Yeah, I definitely heard something click, and we're gonna do a check on our filter caps. And look at that, we are now getting 388. So it does look like the power supply is turning on. At least the primary side is fully active. Let's see, do we get our 12 volts? We do not. Okay, so we're still having some issues, but obviously we didn't replace that transistor. Is anything getting hot? We're still getting a bit of a hot spot, but it is only showing about 43 degrees Celsius, which is just a couple degrees above room temperature, so that is not hot enough to be of any concern. That's normal operation. All right, we're gonna disconnect and replace that transistor and see what we get. We're gonna start by removing some of the old solder that we just added. We'll give that area a quick little clean, and we're gonna add just a little bit of solder to one of the joints and slide in our replacement. Not exactly flush, let's bring it down, there we go. That's better. Add a little solder to the next one. Perfect. And finally the last joint to lock it in. Nope, not quite, not quite. There we go. We have a replacement transistor installed. I'm gonna use the thermal camera and quickly disconnect if anything gets hot because I don't want to damage the replacement components. So let's see here, 70, 80, that's too hot. We're gonna remove. All right, let's see, is that the same spot? Yeah, still the same spot. All right, so we're gonna redo kind of the same process. Spray with alcohol, plug it in. So this time the IC chip is getting much hotter and the transistor is not necessarily drying up as quickly. Whereas before the transistor was immediately drying up. Let's plug it back in. And again, the IC chip is getting hot, the transistor not as much. So let's go ahead and replace that IC chip next. Again, same process. We're gonna start by adding some solder to all the pins. We're gonna add a little bit of flux, and we're gonna use some hot air. And I'm actually gonna also use my iron in tandem, just to help it out a little bit. Oh, there we go. And we'll go ahead and remove some of the excess solder now. We'll use a little desolder wick. Quick little cleanup, remove some of that flux. It is no clean flux, so technically we don't need to, but I do prefer to remove the spent flux so that when we do the installation, it's going to be a cleaner install. Same as before, we're going to go ahead and lock down one of the pads by adding solder to it first. We're going to slide in our replacement IC, which was scavenged from a donor board. Okay, it looks pretty well lined up. Let's lock in the opposite pin now. Now we're going to go ahead and add that extra flux and lock in the rest of the pins. Quick cleanup. All right, let's do one more test. Let's go ahead and spray with some alcohol. Let's plug it in, and nothing's getting hot. It's plugged in right now. All right, same thing. We're gonna be using the thermal camera to see if anything's getting hot. So it just clicked 40 degrees. See down here. Yeah, and it's not more than 43 degrees. So we are no longer getting a hot spot. So it looks like we took care of the issue down here. Let's do a voltage check. Do we get our 12 volts? Oh, we were for a second. Oh, look at that. Okay, so it's better. It's oscillating. Before we had 0 volts. All right, let's see. Do we get our 21 volts to the, oh. Okay, 21 volts to the T-con, also oscillating up and down, up and down. We're not quite there yet, but we are making progress. All right, let's see. 45 degrees. Yeah, it's still not that hot. We're gonna do the same thing as before. We're gonna spray with some alcohol. We're gonna plug it in. And we're gonna see what is getting hot. So it's looking like these resistors are getting hot. So I believe those are 100 ohm resistors. And there are 3 of them in parallel. All right, let's disconnect power. Let's do a quick reading. Divided by 3, I believe. Should be about 33 ohms. So we should be getting 33 ohms total. And that is what we're getting, 33.6. Let's see, what about this guy over here? 1 kilo ohm. 1.1, 1.8 kilo ohms. Okay. All right, I kind of cheated. This component right here on a donor board, it looks like we're getting much higher readings. So we're not going to be doing this purely with a thermal camera. We're going to be using the multimeter to diagnose this, I guess. I was hoping it would be just with the thermal cam, but we're going to want to replace that next. I believe it could be shorted. Let's remove it out of circuit first and see what we get. See if that changes any of our readings. Same thing, we're going to add solder to all the joints. And let's do a new measurement. What is our resistance? So that's now, okay, we're reading 1.5, 2.2 kilo ohms. Let's read to here, 14 kilo ohms. Let's read across here. That appears open. Okay. Let's go ahead and install our replacement. I'm gonna give it a little extra room. All right, let's go ahead and power it up. Just heard a click. Are we still getting a hot spot? Yeah, we are. Oh, but you know what? We're getting a new hot spot. Wait a minute. This is a new hot spot. I don't think it's the same. Wait, let's see. So we're in DC volts. Let's take a look. Oh my gosh, look at that. We now have a steady 12 volts. Wow, all right, let's look at our T-con output. And we're getting a steady 21, 22. It's oscillating a little bit, 21.5, 0.6, 0.8, 22.1, 22.2. All right, so we were making a lot of progress. We're almost there. So I'm not sure what happened. I've been trying to figure this out off screen. Why is that voltage oscillating? But the next time I took a measurement, as you can tell, right now, we're actually no longer getting that oscillation. It's a very steady 21.4. So I'm not sure if maybe I was making improper ground contact with my leads, if they were dirty, if there's something wrong with the meter, but I have repeated this 3 times now, completely discharged the board, and it is fully steady. So I think we are all set. We're gonna go ahead and conclude this as a successful repair. Now, if you have a power supply that you'd like to send in, whether it's a Sony or Samsung or other brand, let us know. We do have flat rate services. You can contact us either within the comments down below, or we'll have a link to our contact form on our website. That'll be in the description. If you found the video helpful or useful, leave us a like, subscribe for more content, and thank you for watching.